So I want to show you a visual of the p-value by doing this example right here. Okay, so this is the normal curve, standard normal curve, that's the z. And a negative 2.23, guys, will be somewhere here because it's negative. Okay, and let me draw the p-value. Since this is a left tail test, guys, the p-value is the area to the left of z right here. Can someone remind me from chapter 5, how do you find this p-value? P-value is the probability that we have a value that is as extreme as negative 2.23 or more extreme, usual or more unusual. That's how we defined it there. So how do I find this area, guys? Do you still remember from chapter 5? It's normal CDF, lower bound, which is negative 1 million. So we need the probability of z less than negative 2.23. If it is a left tail test, guys, your p-value is the probability of z less than. If it is a right tail test, then your p-value will be the probability of z greater than. So negative 1 million, negative 2.2301, and this is the p-value. So it's a probability. Just do it just like you did probabilities in chapter 5. And if I use the calculator, second, distribute, normal CDF, negative 1 million, negative 2.23, 0 and 1, guys. And this is the p-value, 0.0129. And now if I want to make a decision, alpha is 0.01. If you compare the p-value with alpha, you notice that the p-value is bigger than alpha. And if it is bigger than alpha, you fail to reject HO. So our decision is we cannot reject the null hypothesis. Okay, let's see the second example. Find the p-value for two-tailed hypothesis test with a test statistic of 2.14. When you have a two-tailed test, guys, your p-value is on both sides. And he says one of the, z is 2.14. So this is the 2.14. And then you have to shade an area on the left as well, which is with negative 2.14 because it's two-tailed test. So what I'm going to do, guys, I'm going to find this area here, which is normal CDF, 2.14 a lower bound, 1 million is an upper bound, and then 0 and 1. Okay, let's see, what would that be? But again, you will see later that you don't have to do it this way, just to give you a feel, a visual of what the p-value is. Paste. Okay, I got 0.016177, but remember, this is two-sided p-values. Just multiply the answer by 2. Because you have this value, area on the left and area on the right. So my p-value is 0.0324. Which is bigger than alpha. Oh, what is alpha? No, alpha is 5%. He says, so that's less than alpha. You reject HO. Okay. As we said, guys, the steps of the hypothesis test are 5. The first step is to state the null and the alternative hypotheses. The second step, guys, is to change the information given to you from the sample to a z-score. Remember, we have a formula for a z-score, which is mean value minus mean divided by standard deviation. Now here we are given a sample and you are given the sample mean, the mean from the sample. So we're not working with one value, we're working with many values and we'll take their sample mean, which is called X bar. And then we subtract the mean and we divide by the standard deviation. But remember, guys, when you were working with sample means, the standard deviation is not sigma, it is sigma over square root of n. And this is why, guys, that explains why I ask you to do some practice on finding those numbers here, because look at the formula. One number minus another one divided by one number divided by the square root of n. All right. The steps. We're getting close to doing one exercise. Step 1, state the null and the alternative hypothesis. Step 2, calculate the standardized test statistic, which is number 2 right here. And the good news is your calculator will do that for you. Step 3, find the p-value. And the p-value, guys, is an area either to the left of z or to the right of z. So that's why step 2 is important, because step 3 is determined based on your answer in step 2. We either reject the null hypothesis or we fail to reject the null hypothesis. We can never accept the null hypothesis. We don't say the word accept. We just say reject or fail to reject HO. Step 4, make a decision to reject HO or fail to reject HO. And step 5, guys, write your conclusion in words in terms of the claim. These are the 5 steps. Let's take you now to an example. Okay, I'm gonna leave this worked out example. I've already worked out the details, and I'm gonna go to a question where there are no details, which is right here. So that's the very first one, guys. Let's get ready for this. Unfortunately, not all students are present, but students can decide what they want to do in this course. The EPA reports that exhaust emission for a certain car model has a normal distribution with a mean of 1.45 grams of nitrous oxide per mile and a population standard deviation of 0.4. The car manufacturer claims their new process reduces their mean level of exhaust emitted for this car model. So the standard mean is 1.45 grams for all cars, but the company is making a claim that their process will reduce the mean level of exhaust emitted for this car model. Can a student help me state the null and the alternative hypothesis? What would it be, guys? Any suggestions? We know that the exhaust emission is 1.45 grams in general, but a company is making a claim that their new car has a mean level of exhaust lower than that. Yes, less than, I agree. That's the claim. And you guys, once you write, you know, the alternative hypothesis, you know what the null has to be the total opposite, which is greater than or equal to. He says, we know that the population standard deviation is 0.4. So sigma is 0.4. Let's put that, we're gonna need this one. A simple random sample of 31 cars. So N is 31, guys. Is taken and the mean level of exhaust emitted from this sample is 1.21 grams. So X bar is 1.21 grams. Okay. The question is, can you support the claim? Is there enough evidence to support the claim? Actually, I do not put the question here. Is there enough evidence? Is there enough evidence to support the claim? Use alpha equals 5%. So I'm going to use my significance level to be 5%. So the first step, guys, is to state the null and the alternative hypothesis. Sometimes it is obvious how to state the null and the alternative hypothesis. Other times you just have to think a little bit. It says reduces. Reduces, guys, means less than. So less than 1.45, that's where the claim is. And the null hypothesis will be greater than or equal to 1.45. This is called the step one. Step two, guys, is to calculate the test statistic, which is we're going to use to find the p-value. Later, guys, you don't have to do this manually, but I'm just going to do it manually for this time so I can show you how to do it that, but the calculator can do the test statistic. So Z, here's the formula for Z. It's X bar minus mean divided by sigma over square root of N. And watch, guys. X bar is the sample mean, which is 1.21. This is a left tail test, so don't be surprised that Z is going to be on the left. It's going to be negative. So X bar is 1.21 minus. Let's see what the mean is. We will assume, guys, that the null hypothesis is true until proven otherwise. So we're going to assume that the mean is 1.45. That's how we start the hypothesis test. We say we're going to assume that we have faith that HO is true unless if we can prove otherwise. So minus 1.45 divided by sigma, guys, is 0.4 over square root of 31. Let's do this one together. So open parentheses, 1.21 minus 1.45 divided by, open parentheses, 0.4 divided by second and square root of 31. Here you go. I'll just keep it on the screen for a second. And it's negative 3.34. That's Z. Calculate the p-value. If you have a left tail test, guys, the p-value is the area to the left of Z. If you have a right tail test, the p-value is the area to the right of Z. So it's going to be to the left of Z. Okay, which is a normal CDF. Let me just show you a visual of the p-value. Again, guys, you don't have to calculate this by hand in a few minutes. Just give me a few minutes. This is the p-value. How do you do it using normal CDF, guys? So it will be normal CDF. That's why chapter 5 is very important. Negative 1 million, negative 3.34. It's going to be very small. So probably you're going to reject HO. Let's do it. Second, distribute normal CDF, negative 1 million, comma, negative 3.34, comma 0. Oh, why didn't I do this? Right here, negative 1 million, then negative 3.34 and 0.1, guys. Okay, can you read the answer, guys? What would that be? E minus 4 means you have to move the decimal point 4 digits to the left, so it would be 0.0004. Which is less than alpha. Alpha, he says, use 0.01. So p-value is less than alpha. What's the decision? The first one or the second one, guys? Can a student tell me, please? That's what you need to memorize, yeah. Less than. Oh, page 9 is just a worked out example. I worked out the solution for it. So I'm just gonna, yeah, I skipped over that one. I can go back to it later, but I just wanna do a complete exercise. So that's reject HO. So look, p-value low, HO must go. Just p-value low. Low means less than alpha, guys. That's what low to you should mean. Less than alpha, then we reject HO. What's the conclusion? We reject HO, guys, and the claim happened to be in HA. Here's what you say. There is enough evidence. And you mentioned the level of significance that you are using in the problem at the 0.01 level of significance. To support. When you reject HO and the claim is in HA, that means the claim can be supported because you say this is bad. That means the second one is good. So you say there is enough evidence at the 0.01 level of significance to support the claim. Whatever the claim is, that the new process reduces the mean level of exhaust emitted. That the new process, just copy and paste the claim, guys, reduces mean level of exhaust. Emitted in the new car model. So meaning their claim is valid. They made a claim and we were able to support the claim. This is a complete exercise in how to perform a hypothesis test. So guys, again, the first step is to state the null and the alternative hypotheses. The second one is to find the test statistic. Now the calculator is gonna find this for us. Step 3 is to find the p-value. Step 4, reject HO or fail to reject HO. And step 5, write your conclusion in words in the context of the claim. Now, let me show you guys how we could have done this using the calculator. You're ready for that one? Now, what does the calculator do for us? Step 1, the calculator will not do it for you. You have to write it down. The calculator will do step 2 and step 3 for us. It will give us the p-value, and then we compare the p-value with alpha. We say, if the p-value is less than alpha, we reject HO. If it turns out to be more than alpha, we fail to reject HO. So this you have to do yourself. And step 5, guys, is based on step 4. You have to do it yourself. So the calculator does the 2 important steps, which have the tedious calculations. It will do step 2 and step 3, and I'm ready to show you how we can use the calculator. This is a hypothesis test. So when you go to the calculator, you're gonna look for what's called a test. And then you look for sigma. If you're testing the mean, if he gives you the population standard deviation, guys, it's a Z test, just like the Z interval and T interval. If sigma is known, we have a Z test. If sigma is not known, we have a T test. Same thing with interval. If sigma is known, Z interval. If sigma not known, T interval. So since sigma is 0. How do I know it is sigma? Look what he says here. He says population standard deviation. And then I'll go and do a Z test. And guys, watch, because you're gonna do this one in the activity in a little bit. So you hit stat. You go to tests, Z test, and right here, guys, input is summary. Okay, and let me walk you through the steps. Please pay attention to this. Mu0 means what is the assumed value in the null hypothesis, that you assume that it is true until proven otherwise. You just copy and paste this value here, 1.45. Sigma is sigma, whatever he says, sigma is 0.4. X bar, guys, what was X bar in the question? 1.21. N 31. And now let me tell you what this, and I want a student to tell me which one do I select. The one before you hit calculate or before color is what is the sign in the alternative hypothesis. So which one do I choose, guys? The first, second, or third? It's the sign of the alternative hypothesis, because the calculator needs to know what type of test, a left tail test, a right tail test, or two tail test in order to find the p-value. So what is it going to be? First, second, or third? Yes, second, exactly. So it's less than. And make sure to press enter to select it, guys. Now it is selected. And hit calculate, guys. And you will see step 2 and step 3 popping up on the screen. They should match with our answers. What? Z is negative 3.34. Look, guys, negative 3.34. P-value is 0.0004. Look, guys, this is 0.004. So you get the test statistic and the p-value. P-value less than alpha, you reject the null hypothesis. Your claim is in the alternative. You say that there is enough evidence at the 0.01 level of significance to support the claim. And that concludes the test. Okay, let's do another one together. Now we're going to use it on the calculator. So please have your calculator handy, guys. And we're going to show you how to do the 5 steps using the calculator. In auto racing, a pit crew claims that the mean pit stop time for 4 new tires and fuel is less than 13 seconds. So they make a claim that they can replace 4 tires and refuel in less than 13 seconds. And I've seen this on TV, guys. They're very, very fast. They're like 5 of them. One person, each one will change the tire and then one will refuel. And they do it, just in no time. So let's write the null and the alternative hypothesis. So HO and HA. It's about the mean. So you just put mean. And do you guys agree with me? It says less than 13 seconds. So it should be right here. This is the claim. And the null hypothesis is going to be greater than or equal to 13 seconds. That's step number 1. A random section of 32 pit stop times. So N is 32. Has a sample mean of 12.9 seconds. So what they did, they picked 32 times when they changed the tires and they measured the time each time. And the average was 12.9 seconds from 32 values. So X bar is 12.9. Assume that the population standard deviation is 0.19. Once he says population standard deviation, guys, it is sigma. So sigma is 0.19. Is there enough evidence to support the claim at alpha equals 0.01? So alpha, he has to give you alpha, guys. In some stat books, they don't give alpha, but they tell students to assume. If it is not given, assume that alpha is 5%. So if you come across an exercise, guys, where I fail to give you alpha, just use 5% for alpha. Use a p-value if using technology, and it is the z-test. So I'm just giving you a hint here, guys, that it's the z-test. So I'm not going to do any of the work that I did here by hand. Watch, guys, how we're going to do all of this without just by relying on z-test. Ready? So we're going to go to the calculator. We're going to hit stat. From now on till the end of the semester, this is where you go, guys, to tests. Z-test, it's number 1. And you know what's coming after this? T-test, when sigma is not known. Okay. mu0. mu0 is what is, we assume that the null hypothesis is true until proven otherwise. So we have to use 13. Enter. Sigma. is 0.19. X bar, 12.9. N is 32. Any questions, guys, so far? You can stop me at any time. It's very, very important to understand what I'm doing right here. And then now, guys, I need the sign from the alternative hypothesis. Not from the null, from the alternative. It's less than. It's the same as the previous exercise. And let me show you the difference between calculate and draw. For draw, I will give you those two values, but I will draw the p-value as well for you. So let me just show you here. It's a left tail test. So if there is a p-value, it's going to be to the left. But since you didn't see any shading here, that means the p-value is very small, guys. And look, 0.0015, you couldn't even shade this one. That's barely nothing. So that's why you don't see anything. So Z is negative 2.98, and the p-value is 0.0015. And now, p-value and alpha, let's compare them. Alpha, guys, is 0.01. Do you guys agree with me that the p-value is less than alpha? 0.0015. How do you compare, guys? Here's how I compare in algebra. 0, 0, they're the same. 0, 0, they're the same. Third one is 0. Third one is 1. 0 is less than 1. That means it is less. So p-value is less than alpha. And if it is less than alpha, what's the decision, guys? Reject HO or fail to reject HO? Would the student tell me, please?
Is it fail to?
Reject HO.
Reject. When the p-value is less than alpha, you reject HO. Try to memorize this, guys. That's very, very important. And if you reject HO, here's how you start. I'm going to show you a trick in how to write the final conclusion. If it is a reject, you start with there is enough evidence. If it is a fail to reject, you start with there is not enough evidence. So there is enough evidence at, mention the significance level, guys. You have to mention that, because you have to tell a reader that there is a chance that you make a type 1 error there. At the 0.01 level of significance. Okay. 2. If you're doing this work online, when you come to this one, it's going to ask you to choose between reject or support. If the claim, guys, in HA, you use the word support. If the claim in HO, you select the word reject. So since the claim is in HA, it's going to be support. There is enough evidence to support the claim, and then just copy and paste the claim, whatever the claim is. There you go, it's right here. That the mean pit stop time is less than 13 seconds. That means their claim is valid. We supported the claim. That means what they're saying is actually true. It's not false. That is, so then if you can conclude that their claim is not valid, you can go after them and tell them you're doing a false advertisement here. So this is how you check, just if a statement made by people is true or false. You collect data, you collect a sample, and then you study the sample. Any questions here? Okay, so this is how using z-test, TI-84. Okay, let's do one more. According to a study, the difference between 7.2 and 7.3, guys, is he doesn't give you standard deviation of population in 7.3. He gives you S sample standard deviation, so you just use t-test instead of the z-test. According to a study, the mean cost of weight loss surgery is $21,500. You think this information is incorrect. So What would be the null and the alternative hypothesis here? Let's continue reading. You randomly selected 25 bariatric surgery patients and find that the average cost for their surgery is $20,695. The population standard deviation is known to be, so you see, he gives you sigma here, is known to be 2250. And the population is normally distributed. Is there enough evidence to support your claim at alpha equals 0.05? So, according to a study, the mean cost of bariatric surgery is $21,500. You think this information is incorrect? Who can tell me what the null and the alternative hypotheses are? They say it is 21,500. You think this is not correct? Okay, so we have equal or not equal. Yes, I agree. And because it's you who's making the claim, you think it's not correct, that's your claim. It's the question, it's whatever the question is, guys, and the problem, that would be the claim. Doesn't matter who's making the claim. It's just, what is the question? What do they want us to check? They said it's not correct. So that means different from 21,500. Okay. 25 surgery, and it's 25, guys. Average cost X bar from the 25. This is the sample mean. So we'll always give you the sample mean. And then the sigma is 2250 and alpha is 0.05. You see alpha here is 0.05. We'll compare the p-value to 0.05. Okay, calculator. I will allow you guys, when you use p-value method, just to use a calculator throughout, so that will be fine. Z-test, okay. We haven't used data yet, data when he gives us raw data, but he's given us summaries now. So mu0, guys, you have to put the value, assume that the null hypothesis is true until proven otherwise. So it's 21,500. Sigma is 2250. X bar, guys, is 2695. N is 25. Any questions so far, guys? And then what would be the sign here before you hit calculate? That's very important, guys, to pick the correct sign. First, second, or third?
First.
First, yes, I agree. And I'm gonna do a draw, guys, to show you a visual of the p-value. There you go. You see, they're gonna be shading on the other side too, because it's two-tailed test. So Z is negative 1.7879. 2 decimal places. Z-test. Just redo those exercises, guys, when you go home, just to make sure that you still can go back and do the same steps. And this area, guys, doubled is, let me see, 0.0736. You see, you don't have to do any work, just get it off the calculator. Now compare it with alpha. And this is alpha, 0.05. Is it greater or less? 0.0736, guys. Is it more than alpha or less than alpha?
More than alpha.
More than alpha, I agree. So the decision will be fail to reject HO. This is the first time we failed to reject HO. We did the first two questions, reject HO, now fail to reject HO. If p-value is more than alpha, you fail to reject HO. If p-value less than alpha, you reject HO. Now, let me show you how to write the conclusion, guys. I showed you the shortcut. Look, if it is a fail to reject HO, we start with there is not. So fail, you have to have not. Enough evidence at the 5% level of significance. Two, now the word support or reject. Where is the claim, guys? In HA. If the claim happened in HA, you use the word support. If the claim happened to be in HO, you just put the word reject to support the claim. You are saying, guys, that you don't have enough evidence to support the claim. So probably the claim is not right. You just don't have enough evidence to support it. It doesn't mean that the claim is false, but I don't have enough evidence to speak in favor of it. Maybe if I do another sample, I could, but for now, based on the data that I have, no evidence to support this claim. Okay, so what I would like to do, so I'm just gonna stop the lesson right here, guys, and then I'm gonna go and do an exercise together as a graded activity in Socrative. Okay, that will be a fourth question that we'll be doing.